Good morning, students. Welcome to the design and detailing of the RC structural elements lab. In this session, we will be dealing with the detailing of the continuous beam. So now, before going to that, when we will say a beam as continuous beam, a beam is said to be a continuous beam if the beam is having a span more than 1. If a beam is having a span more than 1, then only we can say that the beam is a continuous beam. Otherwise we cannot say it is a continuous beam. Either it may be a simply supported beam or it may be a fixed beam. I move on to the detailing of the continuous beam. So let me explain you some codal provisions that we have to follow while placing the reinforcement. Now this figure will explain you how we have to decide the minimum cover for the reinforcement. According to this, the cover should be greater of 25 mm or the diameter of the bar that you have used for the continuous beam. Out of these two, whichever is greater, so that value has to be considered as the cover. Now, whenever you are placing the reinforcement one side by the other, you have to maintain a certain spacing. That is what we call it as minimum horizontal spacing. This minimum horizontal spacing value is given by diameter of the bar or the nominal or maximum size of the aggregate plus 5 mm, whichever is greater among these two. So out of these two, whichever gives you the higher value, so that value has to be considered for the horizontal spacing. Similarly, sometimes when you calculate the number of bars you may obtain may be more, which cannot be provided in a single horizontal layer. Therefore, we provide alternatively one above the other. So, when we are providing it in the layers, a minimum vertical spacing has to be maintained. So, that vertical spacing is 15 mm or 2 by 3 of the nominal size of the aggregate or the diameter of the bar. Out of these, whichever is maximum, that you have to going to consider it. But these three conditions will satisfy only when the diameter of all the bars are same. If the diameters of the bar are different, then what you have to do, you have to consider the larger diameter of the bar and correspondingly other conditions has to be considered. Whenever there is a beam, whether it may be a simply supported or continuous or a cantilever, so there are some main types of reinforcement. One is the main bars, which is provided at the top or the bottom. Hanger bars again, which is provided at the top or bottom. For simply supported as well as continuous, it is provided at the bottom, then that is main bars, whereas for cantilever it is provided at the top. And stirrups for all the three types of beams. And the side face reinforcement will come into picture only when you have the depth of the beam more than 750 mm. Now we are going to see the table which gives you the minimum diameter of the bar as well as the maximum diameter of the bar that you have to consider. If we are using main bar, the minimum diameter is 10 mm, the maximum is 32 mm. For hanger bars, the minimum is 8 mm, the maximum is 16 mm. Stirrups, the minimum is 6 mm, the maximum is 16 mm. This will give you the minimum area of reinforcement. So whenever you are going to do a design, so if you are getting this area, the less than minimum area, so we cannot ignore the area of reinforcement. In such case, in any type of beam, at least you have to provide the minimum reinforcement also. So to calculate the minimum area of reinforcement, so in the longitudinal reinforcement, we are going to use 0.85 BD by F of 5, where B is the breadth of the beam, D is the effective depth, F of Y is the characteristic strength of the steel. Whereas for the stirrups, the area should not be less than or it should always be greater than 0.45 BSY by Fy, where SV is the spacing of stirrups. Whereas for the side face reinforcement, it is only when the depth is more than 750 mm and it should be minimum of 0.10% of gross area, that is B. Now, this is regarding the spacing of the bars. So whenever it is a main bar, the minimum spacing should not be less than 5 mm or the size of the coarse aggregate. And whenever it is a stirrup, the minimum is 50 mm, maximum is 75 times the effective depth or 300 mm. And whenever you are providing the side face, the maximum is 300 mm. That is the maximum spacing of bars. This diagram will give you completely the details of longitudinal reinforcement. Now, before I go to that, one thing we should make it clear, whatever the span they have given, definitely it will be a clear span, that is from outer face of the supports. So to calculate the effective span, what you have to do, you have to take half of the support width. So half of the support width plus clear span plus half of the support width will give you the effective span. And as I already told, for continuous beam, the span should be more than 1. If the same clear spans are maintained for all the spans, the reinforcement detail will also be same. But if the spans are different, even the reinforcement value will also change, because in majority of the places, the reinforcement details will be decided based on the effective span. Now, the one more major difference between the cantilever beam as well as the simply supported beam to the continuous beam is, in both cantilever and continuous beam, whatever the reinforcement you are going to provide at the bottom, it is all the tension reinforcement, that is for the positive bending moment. But in continuous beam, since the beam passes over the supports, at the supports there will be a development of one more kind of moment called negative bending moment. And for this negative bending moment, you have to provide an extra additional negative reinforcement only at the supports, not at the mid span. Right, so now we'll go through it. So now if I am taking the mid span and if I am considering the bottom reinforcement, that is positive reinforcement, so at the middle they have told 100%. It means if I am having the 6 bars of 20 mm diameter, all the 6 bars will be provided at the middle. It means again, since the bending moment is less at the support, all the 6 bars will not be provided throughout the length of the span, so the certain bars will be cut-tiled. Then if I want to cut-tile, they have told 30%. It means almost if it is a 6 bars, I can provide up to 1 or 2 bars can be cut-tiled. Right, therefore if I am providing the 6 bars, usually what we do is we provide 3 bars throughout and 3 bars will be cut-tiled. Then up to what distance it will be cut-tiled? It will be cut-tiled at a distance of 0.1 of the effective span from the center of the support. Therefore, if I take the bottom reinforcement and if I take at the middle, we will be having 100% reinforcement. That is, all the positive reinforcement will be provided. But if I take the bottom reinforcement close to the support, so 30% of the bars will be cut-tiled. That is about bottom reinforcement. Now, when it goes to the top reinforcement, anyhow, you will be having 3 layers. This is the first layer of reinforcement. This is the second layer of reinforcement. This is the third layer. Similarly, here also this is one layer. This is second layer. This is third layer. The hanger bars are the one which is going to take the compression that will be provided throughout the length of the beam. Therefore, if I take the midsection at the top, you can see only the 20% of the total area of the steel can be provided. It means the 2 hanger bars will be provided at the top of the beam. Then I told whenever you have the continuous beam, there will be a development of negative reinforcement at the support. So that additional negative reinforcement has to be provided. So that additional negative reinforcement is the second layer. From the face of the column, it will be provided to a length of 0.25 of the effective length. So this is the face of the column. From here to a distance of 0.25 of the effective length, we are providing the negative reinforcement, and that will be equal to 60% of the reinforcement. Right? For example, if it is that is negative reinforcement. Along with that, we will be providing the one more reinforcement. So that is from the face of the column to a distance of 0.15 of L1. Therefore, if I take section close to the column, close to the support, we are having 100% reinforcement. So hanger bar, negative reinforcement, additional reinforcement. So if I take at distance, we will be having only 60%. It is hanger bar and negative reinforcement. So if I take exactly at the middle, so I have only 20%, that is only just hanger bar. The same thing will be applied here also. So whatever the length you are going to provide from face of the column till here, all these will be the development length LD, which is equal to 47 times the diameter. We consider the size of the beam is 230 into 500, clear span is 4.5 meter, wall thickness is 300 mm, main reinforcement, that is positive steel 4 number of 20 mm and negative steel 4 number of 20 mm diameter. Stirrups 2-legged 8 mm diameter stirrups at 150 mm near the column for a distance of 1 meter and 300 center to center in the remaining portion. M20 is the grade of concrete, AP415 is the steel. If I take this now, anyhow the spacing, since the shear is more at the support, they have provided the close spacing up to a distance of 1000 mm, that is from here to here from the face of the column. It is 2-legged 20 mm. Whereas in the remaining portion, they have provided 2-legged 8 mm dia at 300 mm center to center. Here it is 2-legged 8 mm dia at 150 mm center to center. Now, I told you there are 4 number of 20 mm diameter bars, which is the positive reinforcement. So therefore, if you see this line, this is my positive reinforcement. This is my positive reinforcement. So if I take the section at the middle, at the bottom, have all the 4 bars. Whereas from here, you see this, that is 0.25 of L1. So that is from here to a distance of 0.25 of L1. I have cut tiled the 2 bars. Therefore, if you take here, you have only 2 bar of 20 mm diameter. This is all about your positive reinforcement. Now, when it comes to negative reinforcement, anyhow hanger bars will be there. So therefore, you are going to provide 2 hanger bars of 20 mm diameter, that is fixed. Now they have told 4 number of 80 mm, 4 number of 20 mm diameter bar as negative reinforcement, which is provided only at the support. Therefore, here to a distance of 0.25 of effective length from the face of the column, we are going to provide again 4 bar of 20 mm diameter. And along with the hanger bars as well as along with the negative reinforcement, we are going to provide one more additional reinforcement, which is to a distance of 0.15 of effective length from the face of the column, which is again 2 bar of 20 mm diameter. Therefore, if I take section at the middle, so at the bottom I have 4 bar of 20 mm diameter, at the top I have 2 bar of 20 mm diameter. If I take section exactly next to the support, at the bottom I have 2 bar of 20 mm diameter, at the top I have 2 bar of 20 mm diameter, which is hanger bar, then 4 bar of 20 mm diameter, which is negative reinforcement, then 2 bar of 20 mm diameter, which is additional reinforcement, totally 8 bar of 20 mm diameter, which can be placed in 2 layers. Whereas if I take somewhere here, that is at a distance of 0.15 L1, then you have 2 number of 20 mm diameter, at the top 2 hanger bars, then only 4 number of 20 mm diameter will be there. If I take again further, then you have 2 number of 20, 2 number of 20 at the top, then remaining 2 bar of 20 mm diameter will be there. This is how we have to do the negative reinforcement. So this completes your detailing of the continuous beam. Thank you.